Hey, welcome to IT PhD channel, and today I'll tell you about assembly, disassembly, how to read assembly language, how to work with it in some disassembly environments. So let's start. I hope you watched my previous video where I explained how processor and random access memory works. So basically assembly, it's language which describe interaction between registers at your central processor unit, at your CPU, and memory. It's basically all programs for when you write your first hello world. It's you define certain interaction between your central processor unit and memory of your computer. So basically this program which we see here, hello world, it's in assembly language, which it's translated eventually when you compile it. It looks something like this, or something like this, or something like this. It depends on your architecture. So right now it's two main architectures. It's x86, or we could call it like 86, and ARM. So ARM, it's in your mobile devices, mostly these processors, and x86, or right now they are already like 64 with support of 86, it's in your PC. So assembly language is different, but even if we will take only x86, these three here you see three assembly languages, they are different even for one architecture. So this, for example, it's Microsoft assembly. This is NetWide assembly, the most popular for learning. So if you learn assembly for serious, NetWide assembler, NASM, it's one of the best choices. And GNU assembler. I use mostly GNU assembler for like looking into how stuff works. And actually when you reverse some programs, for example, let's today reverse calculator. So let's take a look at the calculator, how it looks inside. For reversing, you will mainly use MASM. How it's different? First important thing, very easy to find out, it's by looking into comments. So if you use GNU assembler, it has comments which start with grid. So if it's NetWide assembler, its comments start with semicolon, like this. So comment. It's kind of how to understand easy difference. And another thing, it's which is the most confusing thing, it's how it's moving from right to left to right. So most important command in assembly, it's move, and in any dialect it's the same. The difference is that, for example, in Microsoft assembly, you go from the right to left. So your destination, your source to the right, like for example it's here data. So in MASM it's like source, destination, like this. So for example, you move data to this registry. So in GNU assembly it's vice versa. Very confusing. What do you think? But it's how it is. So in GNU assembler you have this is your source and this is destination, so it's vice versa in GNU assembly, like this. And it may be very confusing, so when you just start working, just choose something what you want. But I personally use mostly GNU assembly because I like GNU stuff. So it's another difference, that in GNU assembly you should mark your registers with percent and like stuff with dollar. And in Microsoft assembler or in NASM, In NetWide assembler, you do not need it. So it's two main difference. It's kind of the most important ones. So let's start. Let's just take this hello world and compile it. So we will understand how actually it works. So I'll use PowerShell, but actually we could even use Linux shell. So if you didn't have WSL at your Windows, if you work at Windows, install WSL. I made a video about it. So it's basically Linux. Linux, which is accessible from anywhere, and it's very nice. So when we compile any program, for example, this hello world, let's compile it. We use GCC here, so GNU compiler, and we just could say like this hello .c. Yeah, it's a bit slow, my computer. So if we will do it like this, it will provide us executable file out. So if we will try to run it, it will already work. Yeah, we could make gcc hello.c output it to like hello.exe, but it's actually okay, I'm sorry, it's not com but c. It will make exe file and it will work the same. The thing is that when we do it, we transform this code to machine code. And how machine code looks like? It looks like zeros and ones. So this is a hex editor. So any program which you have, like exe program or out program. In Linux, for example, you do not have even extensions for your programs. So you could compile to the file like hello. And then this will be also executable file and you will be able to run it like this. So in Windows, we run only executable files or com files for all those stuff. In Linux is different. Anyway, so all these executable files, we call it binary files. They have such stuff inside. So it's basically zeros and ones, but it's in hexadecimal representation. But actually it's zeros and ones. So in this file, you may be curious to find interesting thing. In this file, it's possible to find hello world actually. What we have inside. So if you would look at this file, you will, yeah, you see we found this place where hello world. So this symbolic stuff, it's possible to find it inside programs, and we could even make funny thing. We could change it. We could make like write hi world, and now we save it. And now if we will run this binary file, okay, hello.exe, we will see hi world. Why it's so? Because it's just inside of this program at this particular spot, this string stored of such space, but we can't change space of this file, of this string, because it's defined in assembly. So here we do not need to define the size, but in assembly we should do it. We should define size of any stuff which we put here, because in assembly we put everything to registers, to processor registers, and they basically they do not have types. We need to define certain size of anything which we put here. So basically, yes, this is our binary file. Any file will look like this, any executable file. And but how we get it? How we get it? Actually, we could let's just clean all this stuff and try another thing. We will try to compile it step by step. So let's open our Linux bash and let's do this like this: gcc -s and hello.c. And yeah, let's just like this. It will give us S extension. What does it mean? It's actually assembly language. So we made the translation our compiler made a translation from our code, from C code, to source code, like to assembly language. It's a bit bigger, than what we have here, a bit bigger. But we could clean up it, and still we see the same structure. So we see the same stuff here. Work with registers. So if we will make like this, it will be easier to see. We also have like data section, we have text section, and it's what we have here, and some additional variables. By the way, it could be different, depends on the system where you do it. So if you use not the GCC but other compiler, like Clang, for example, you will have different output here. So different assemblers, different compilers, they have different stuff, and some have, for example, optimization and other interesting things. So it's how this source file looks, and then we could make this source file, make it a binary. So we make like GCC hello C, hello S. Let's output it to like hello. And now we have this binary file. We will run it, and it will say hello world. So we made from from assembly, we made this binary file, which is fun. Now let's try do other thing. Let's try to use assembly language to understand what's happening actually, how this thing, why it looks like this eventually. So let's go vice versa. Let's delete this stuff. And here we have very simple thing in assembly language. We have write function, write, which actually put a message on the screen. The size of this message is 13 symbols, because if you will calculate all this stuff, it will be 12. And this is escape sequence, which means like another one more symbol. That's why it's 13. It's first function which we will write, and it's basically this stuff. So this write one message 13, it means this. And another thing, it's exit from the program, and it's this stuff. So every assembly language program has different sections. There is a data section and text section. Maybe you remember in my past video I told you when I draw random access memory, there was text section. It's where your operational system puts your executable file. So basically this is the text which put it to this executable to text section, and this is data section. Yeah, you see, it's like global static variables. So yeah, it's first section and this second. Then every program needs entry point. So for assembly, it's like you use a global start, traditional thing. So here we have the same stuff. So it's like entry point. So program will start from here. And then we have most important command, it's move, which basically put first system call to this register of your processor. There are a lot of different registers, like most important are like 8. You could just Google it or watch at my website. I made an article about them. But for now, we will just go through it. So we move to this register, move 1, which means system call write. Then we move like std out, standard output, to these registers, to this register. Then we move our message, which is here in data section. So it's ASCII, just a string, which we move to EGX register, to ESI register. We move actually not the string, but the address. So we move the address in random access memory address to this register. And finally, we move size of this string. And then we perform syscall. So this stuff will be be returned. So after we did it, we just exit from the program. We again move exit syscall. Then we return it. We return a no 0. We put a 0. Yeah, by the way, there is a mistake. Yeah, it should be like this. We put our value, 0 value. It's like XOR. It's just a way to do it. You could use move for it to move 0, but it's kind of cool hacker way to do it. Not a cool hacker, but it's traditional assembler thing. And when we perform syscall, so and return. It's how it works. So let's compile it. Let's compile our assembly. So we will take a look today at a GNU assembler, not white assembler, but you should just take a look at how it looks. It looks almost the same. So we also have length, message, kind of this system calls, and exit command. Then, so in Microsoft assembler, it's also kind of the same stuff. And actually, you could make loads different of ways to show hello world in assembly. It's just one of the possible. So let's try to compile it, our assembly, to the executable file. To do so, we use as command. So we take a source file, as assembly, which means .s. By the way, again, I want to say that this is Linux terminal, so I use GCC compiler, which include by default as assembler. So if you do not have it, you could just install network assembly with such command and work with it. But yeah, I prefer just GNU. So how to do it? We need assembly, then name of the file, gas.c, and then we just put output. We want to make object file. Let's make it like gas0. Ta-da! That's it. We made object file, which basically it's not yet done, because this is object file. It's not linked yet. So we see already here hello world. Yeah, we see some stuff here, but if we will try to run it, it wouldn't work because there is no executable codes in it. So first we need, now what we need to use loader. LD means loader, and to link it. So we use gas.o, then output, and like the name, like gas. So now if we will run it, it will say hello world. Great. So if we will compare, if we will open our object file and compare it with binary file, you will see there are some differences. So yeah, so they almost the same by size, but in executable file you have huge empty space, empty section here. Yeah, it's how it works. Now, important thing to understand assembly. Actually, most of people, they learn assembly not to write in it. I mean, okay, you could use to write assembly for microcontrollers, for a lot of stuff. It's really useful to know it, and it's great language. It's very interesting to work it. But most times you learn it because you want to reverse something. So you want to get some executable file, for example, calculator. If you will try to look into calculator code, you wouldn't really understand, and you want to change something. For example, in the calculator, you want to have like a new function, and you do not have source codes to perform this. So, for example, you want like to move like button to another place or to add new feature, and you do not have source codes, so you still could do it. Sometimes it could be illegal, so beware. But in terms for calculator it's open source software, so we wouldn't make any harm here. So for reversing you use different tools. There are like IDA, traditional tool for reversing, but I like 2 or 3 years ago, Ghidra, it's a very powerful Java reverse program, become open source. So now you could use it. You could use Ghidra for disassembly, and it's very fun. Why to use it? Because it's actually much easier to learn assembly, not by actually writing programs like this, but actually by reversing stuff. So you could take your favorite old game or just Hello World, which we just created. So you could just take your executable and drag it here and look into it. Look at these zeros and ones with disassembly mode. So let me show it to you how it works. I just create a project, and I just drag and drop here our source file. And basically when you open your source file in hex editor, yeah, let's open it. So you see these zeros and ones, and here in disassembly you also see kind of zeros and ones. So let's load. Okay, so here you see also zeros and ones, but disassembly program, it's convert them, these zeros and ones, into real assembly commands. Because actually there are some people who could manage to read this stuff, but not much of them. I think like 10 people in the world could do it easy. But with these programs, disassembly programs, you could convert your code to even C language. So you will have real C language. You wouldn't even have just assembly, but you will have C language. So what we see here, it's actually binary stuff here. First we see address. This is address of the code in memory. It starts not from the 0. For example, in this program, you see it starts from a 0. Because it's just simply a viewer. If you will take, for example, Notepad++ and will put your code into Notepad++ and open it in hex editor, it will also, hex editor, yeah, it will also start from 0. But in real world, it's nonsense, because in real world programs, they do not start from 0 in our memory, because there are some executable codes and other stuff. So they start from other. So this is an address of certain stroke, and here you see the value in hexadecimal, so in binary format, and then you see assembly command, which is what we need. So actually every stuff here you could easily translate it exactly, so without loss of information, to assembly code. So here we see that here we define some variables. So db, ds, it's different types of like double word, different types of variables. Then we load some stuff here, so we see has a fun function. And here we move our register. So as I showed you here, in our example of assembly here, yeah, it looks Ghidra is its use Microsoft assembly here. It's more close not to this one, but to this stuff, or yeah, to this stuff. So you see that what does it mean, this move? It means that we put this value to this register. this value to this register. So it's basically what we had in our code. Oh, I have twice opened it. It's all right. So it's basically what we had. Even here, you could just recognize this stuff. So it's possible, by the way, it's funny thing that with move command, it's possible to write any program. And there are very funny projects like people who rewrite a Doom game only with move registers. So it's funny because you could make all kinds of comparison with move. So yeah, see, here you see system call. So all this stuff we just went through it together. Do you remember? And this syscall, and now move xor syscall. So it's basically how it works. So you put these registers, value to registers, then you put our message from data section, then you return. And yeah, it's how it goes. And some other stuff where it includes some other stuff based on your system. So thing is that these programs, what they could do funny things. They could actually make try to disassemble stuff. So they could try to show the code which is behind of the assembly in C language. So right now our decompile, what it said that okay, we have here one function and it has like 2 system calls. It's what he see from this disassembly. The problem is that there are only one function, so not much stuff to analyze, and Ghidra kinda useless here. But if we will take here a calculator, it will show us much more stuff. So let's put it. Okay, so this is calculator code, which is actually open source, but still. And here you see again addresses, assembly, machine codes in binary, and assembly language. So each this assembly language sentence, you could actually just click on it and find its translation in C. It's not always there, but in a lot of times there. And for example, this is certain data here, and just important thing here to understand that you translate stuff into C language, so backwards. From zeros, you see then assembly language, and then this assembly language with this decompiler module, you could look into it. It wouldn't have any variable names. It wouldn't have function names. So people who reverse stuff, they have to call it. But for example, we could like rename this global value. So if you know what is it, you could like call it like this is, for example, like button. And okay, let's make it like this. So it's what you do, like you mark your code. Eventually it becomes possible to read it and to apply different changes into the code. So it's how disassembly works, and by working here, it's the best way to learn assembly. So actually it could be fun to write this kind of stuff when you just start, but much more useful and interesting it's to take certain program and for example old game. I like to disassemble old games which do not have source, and you could make some updates or patches in it to improve it. So here you see this code, and it's very easy to read it actually. So for example, let's practice a bit. Again, we have move, so we move this pointer to this register. It's the beginning of a function. Then we compare CMP, compare this register and this register. So in EIX we have this pointer, so we compare these two values, and jump if not z. So when assembly language make compare operation or some other operations, sometimes it puts certain values to as they called zero flags or some other flags. So there are a lot of different flags, and in this case, so when it compare this value and this, if the result it's not 0, then jump here. So if it's a 0, it will continue. The thing is that this assembly and any programs, they are very straightforward. So it's the same as when you kind of write your hello world. The program starts from the top in your main function, and then it goes one by one. In assembly, it's kind of the same. It starts from here, and it's just make all the instructions, give instructions to processor one by one. And here it's the same thing. The thing is that, of course, every program has a lot of functions. And for example, if we will make a function here, like call it gas, like this, and we'll put it somewhere here, and we will define it like gas, and it will return 1, for example. So we will have here jump to certain place, because the code will go like this, here, then here, and in this place it will jump to this function, and then it will return back, and then it will go return, because this code in assembly, it will be also in different places. So we will have here jump instruction in this case. So here we will also have a lot of jump instructions. So most used thing when you reverse stuff, or when you reverse stuff, is jumping. So if you want to change something in program, you just replace this instruction with some other instruction which jump to other place. So it's basically most important thing is jumps. So for example, let's take a look at this place. So move to this register. You see it's R6. What it means? R6, it means that it's 64 register, while EGX, it's 32 registers. But if we will make like AX, it will be 16th register. But yeah, you could look at just specifications of 86 architecture of the processors to understand this stuff. So then we will test. Test it is kind of close thing to compare. So compare these two values, and if the flag of this which was applied after this comparison, if it's Z0, then jump 0. So if it's 0, then it will jump to this function. So we could click it in our decompiler, and we will come here. So it's really easy to understand how function work, where it goes, where it put you. So yeah, XOR, it's like comparison. So actually, assembly, it's not hard language to learn, because all these commands, they're not really, there are not too much of them. They're quite easy to remember. And the problem is that you need to learn registers of processor. It's what I told in my past video. You need to learn assembly. You need to learn how processor works, which registers it has, and learn how processor works with memory, to know about stack, to know about all this section in your memory, and how these registers filled with them. So it's what you need. So actually it's most likely like theoretical knowledge you need to understand this stuff to work. But actually even from 0 you could start disassembling some stuff and change it. It's very fun. So it's kind of most of the stuff which I wanted to share with you today. And next time we will go in C language, because as you see, C language, everybody must know it. So here we have assembly, and it's translated to C language, and C language much easier like to understand for us than this stuff and change. So anyway, if you learn assembly, you will need C language. If you program in if you program in Python, you will need C language. Any programmer needs C language. And actually, it's nice to know a bit assembly, understand how it works, like which I showed in my video, because this gives you understanding how all programs which you code works. Thank you very much for watching. I hope this video helped you. Please don't forget to subscribe at my channel. I make much more videos and I need your support. Have a good day. Bye bye.